Hi, we're back. A recap from last time. In the last operation, we've done the facing, we've done the center hole, and we did the parallel turning up to 28 millimeter for plus minus 105. Today we want to cut this groove, 3 millimeter, and that length from the edge to where the groove starts is 55 millimeter. Now to cut a groove, we need a grooving tool. Here's my grooving tool. Now this grooving tool is 3 millimeter, so that's fine for what I want to do. And it's also a replaceable tip. The same tool can be used for parting off. In other words, when we talk about parting off, we talk about cutting right through the material, all the way to the center. Unfortunately, I've tried it on this lathe, and this lathe is not one of the best quality. So struggling a bit and vibrating too much if I go too deep, which can cause the cutting tool to break. So I'm not going to use it for parting off, but I'm definitely going to use it for grooving. Once again, it's very, very important that your cutting tool must be center height, especially when you do grooving. If it's just below the center, it's going to dig in, and if it's above center, it's just going to rub. So I have to set it up extremely accurate for center height. Now what's the process here? I'm going to bring the cutter till it just touches the side here. Once it touches the side, I'm going to bring it out. And remember, from there to there, according to my drawing, is 55. So if I bring it across 55, it's still going to be at that position there. So I have to move another 3 millimeters. So in total, it's 55 plus 3 is 58. So I'm going to move it 58 millimeter in total. I also have to make sure that my cutting tool is exactly square to the surface here. Otherwise, my groove is going to be skew. So let's do it. Make sure for center height, and I can see it's at least about 1 millimeter above. So slightly, and there it's center height. Now I'm going to make sure that my cutting tool is straight to the surface here. I normally just use a piece of white paper, put it underneath here, move it forward, and make sure that I see between the workpiece and my cutting tool equal amount of light. That means my workpiece is sitting square with my workpiece. Now, I have to move the workpiece for 58 millimeters that way. What I'm going to do is I'm going to make a touch here. Bring it forward. Get my collar reading here to 0. Take it forward till it just touches. Take it forward till it just touches. Once you can start your machine. So it's just touching. So I got my reference. From there, 58 millimeter. Now on this machine, on this collar here, each little line represents 0.15 of a millimeter. So I have to use my trusty calculator. 58 divided by 0.15. 387 lines. Well, 386.6, so we'll make it 387. One revolution here is 95 lines. So if I go from there to 0 again, I've moved 95 lines. If I go again, 95 and 95, 180, 190. So I'm at 95 plus 95, 190. Go to 0 again. I'm at 285 to 0 again. I'm at 380 and I must go 387. So I just have to go. So I'm at 380 and I must go 7 more lines. So what that means, if I have moved my cutting tool for 58 millimeter, if you want to double check, you can just use a ruler. Just to, obviously a ruler is not that accurate, but it will just make sure that you have done it correctly. 55 millimeter. Now, when it comes to grooving, it's very important that you select the correct speed. I do find that the slower you can go, the better your result is. This diameter now at the moment is 28. There where the groove is, I must take it in 5 millimeter on both, well 5 millimeters, so I'm going to bring it down from 28 to 23 millimeter. So I'm going to move in 5 millimeter, remove 5 millimeter, which will take me to 23. I'm going to reduce my speed to 70. Remember, if it doesn't want to go in gear, just wiggle your chuck around. I'm not going to use automatic feed, I'm just going to use manual feed. Now I'm going to take my cutting tool forward till it just touches. And there it's just touching. The moment it touches, I zero my reading here. And I must go in 5 millimeter. Each line represents 0.5. So it's going to be 5 divided by 0.05. It's 100 lines that I must go in. Use my cutting fluid. And here you'll find you might have to go in slightly, out slightly, in slightly. You have to go slowly, don't go too fast, because you're definitely going to break your tool. And remember, I'm going to go 100 lines. There I'm already at 20 lines. And you can see I'm using 2 hands. Because I've got far better control with 2 hands. I don't touch that one, I don't put my hands, I use hands on, yeah. "50 lines. Make sure you get nice cutting fluid there. 60 lines. 100 lines are coming up. And now I'm at 100. So that now will give me a diameter of 23 millimeter where the groove is. I can use a stone just to break the sharp edge in there. Quite often in a groove like that, an O-ring or something will fit, and if you've got a sharp edge, it might damage the O-ring. So I'm just breaking that sharp edge using a stone. So there's my groove. So from there to there it's 55. The groove is 3 millimeter deep. 2.5 millimeter deep, which is 5 on both sides, which will take the diameter down to 23 millimeter. I have to bring the workpiece now up to an exact length of 100 millimeter. That means I have to cut it here. I can use my parting tool to part it off, but I already tried it on this machine. This machine is not the best machine, so I'm rather going to go to my power saw. So 1 minute, and then I'll be back with the workpiece at the power saw. Instead of parting it off, I've sneaked off to the power saw, and it was a relatively quick process of sawing it off, obviously longer than 100 millimeter. But you can see one of the things is this little piece of metal sticking out here. So if I'm going to try and remove that on my center lathe, you'll find that that might cause your tool to break. So I'm just going to use a file. Just remove that burr sticking out there. I can also use my pedestal grinder just to remove it so I won't break my cutting tool. Right. Using my vernier caliper, I'll find at this stage my workpiece is plus minus 107. That's quite a bit. I should have got it a little bit closer, but it means I have to remove 7 millimeter to get it to be exactly 100. Now I can clamp my workpiece. You can see that all the machining on the diameters was done one time. And the reason why that we done that is to ensure that the whole workpiece is parallel and centric. If I have used a short workpiece like that and I had to turn it around, then it will not be running centric. So I'm going to do my facing once again to get a nice exact dimension. Make sure my feet goes in the right direction. 460. So there I got my face nice and straight. Now once again, what I've done now is I've taken my, let me just move it back. I'm going to take my compound slide forward to 0, never backwards to 0. The reason for why I'm not going to take it backwards to 0 is when I want to cut and I want to take it forward again, that amount there, that is known as backlash and play. And unfortunately, depending on the quality of the machine and the age of the machine, that becomes worse with time. So that's why if you want to take a proper dimension or cut a proper dimension, you always take it forward to 0. I'm going to remove my workpiece here so I can get a measurement. And now I can measure accurate using my vernier caliper. You can see how I hold the vernier caliper. I find students do all sort of funny things. It's not only reading it, it's also measuring correct. So I got my vernier there, put my workpiece there, move it forward, and I can take the reading. And I can see at the moment it's 55.7 millimeters. So that means I have to remove 5.7 millimeters. That's quite a bit. Remember to remove on the right side, not on the 55, but on the short side. 5.7 millimeter. Each line here represents 0.25. Remember to double check. This one was 0.15, this is 0.05, this one is 0.025. So it's 5.7 divided by 0.025 is 228 lines. So that's quite a bit. Gonna just touch, and I'm gonna go 40 lines at a time. Can use cutting fluid, but mild steel is not too hard. Don't move anything, come back. We'll go another 40 lines. And I'll do it, I'm at 80 now. And I'm going to repeat this process till I'm reached 228. My last few lines are going to go less. And then I'm going to use automatic feed, just so that I can get a nice smooth finish. So once I've removed 228, with the last few lines, a small cut, automatic feed, get a nice finish. My workpiece should be exactly 100 millimeter long. You'll see that on this side, I'm not going to put a chamfer. And for the simple reason is this workpiece have now to go to the milling machine. Just get it to the center. I'm not going to put a chamfer because this workpiece now have to go to the milling machine where we're going to cut a triangle or a square and a hexagon as well as a keyway. So on this side, if I put a chamfer, it's not going to serve any purpose because it's going to be there on the milling machine. So we're ready to go to the milling machine. So let's recap. What have we done? We've done one of the most difficult machining processes, and that's grooving. It's not so difficult. It's just a little bit nerve-wracking in terms of making sure you got the right feed and the right speed. If your speed is too high, you'll find it vibrating and chattering. You have to use hand feed. You can't use automatic feed. So you have to feed in with the right amount, come a little bit back, go in a little bit, make sure you use plenty of cutting fluid. Then after that, we could have parted it off. Unfortunately, this machine of ours is not powerful enough to do that parting. So I just used the power saw and then I brought it up to exactly 100 millimeter. Right, so our workpiece are ready to go to the milling machine. There's one more machining operation I would like to demonstrate for you on the center lathe, and that is drilling. Now, I'm going to drill quite a long, deep hole into a workpiece, and I'm just going to take this this piece of material here. And I'm going to drill a hole of, I think this is a 12 millimeter drill. Sorry, 14 millimeter drill. I'm going to drill a hole of 14 millimeter deep in here, but I'm going to drill it quite deep. And this is where the problem comes in, is when you drill deep. A lot of students force it, and they tend to break the drill, and a drill like that is quite expensive. So how am I going to perform my drilling operation? Just remove this work here. Put my workpiece. And I'm going to just give it a rough facing there. Before I can use a large drill, one of the problems you'll experience is if there's no center hole, the drill tends to run around and it will never catch exactly in the center. So to do that, we first have to machine or drill a center hole. I'm going to use a larger center drill. Cutting fluid. Remember, you go in and slightly out. Slightly out. There's my center hole. Now I can drill my large hole. Now, it might be necessary when you're going to drill, for example, a hole of 20 millimeter. You can't go directly to 20 millimeter. For the simple reason, it's too big. It can't cut it one time. So you might have to drill 14 and then go to 18 and then to 20, or 14 and then to 20. Another thing you have to keep in mind is that with drilling, for example, this drill bit is 14 millimeter. The hole there that you're going to drill will not be exactly 14. It will be slightly larger. So if you want to get a hole that is an exact dimension, say 14, you'll have to use a 13.5 millimeter drill. So when you drill, it will come up to, say, 13.7. And then after that, you'll use a reamer. Now from reamers, you've learned it in level 2. There are different types of reamers, but the main function of the reamer is to give a hole that is an exact dimension with a nice, smooth finish. So a drill bit doesn't give you an accurate hole, more or less. So I'm going to put my drill in here, and I'll have to slow down my speed. I'm going to slow it down to about 115. In here is not properly in gear. There's it. And plenty of cutting fluid. So it's not properly in a spindle. Just get it in properly. I've taken it away too quick. Let me just face there. You'll see with drilling, I'll go in and slightly out. And the reason why I'm bringing it slightly out is so that I can get the cuttings away from the cutting face. If my fluid gets choked up with cuttings, it will cause the drill bit to break. And you can see I've slowed down the speed quite a bit. So from time to time you can bring out your drill bit completely. And using the measurement on your spindle, you can get to the correct depth that is required. Remember to bring out your drill so your fluid can get clean. Go in again. As much cutting fluid as possible. You can listen to the noise. That's why I prefer not to wear hearing protection or ear protection, as I want to make sure that I can hear if anything goes wrong. And there's my hole. If I'm going to go a larger hole, then we refer to it as boring. And for that, once we reach a certain diameter, I can switch over to a boring bar. The boring bar allows me to get a hole to be in exact dimension with a very smooth finish, but unfortunately you are limited to the size of the boring hole, and that will limit you to the size of the hole. Right. What have we learned today? We've done all the machining on a center lathe for our ISAT project. I demonstrate some center drilling and drilling. The only thing that's going to be left for me now is to clean my machine, make sure that it's dry and slightly oiled. And a reminder that at the bottom of the screen there's some contact information. Feel free to contact us at any time. We will assist you as much as we can.